Jakarta, like many modern megacities around the world, is defined by its relentless motion and extreme physical density. By the year 2025, data projects that 60.7% of Indonesia's population will live inside urban centers. But this massive migration into the cities is failing to generate proportional economic power. While urban population growth is aggressive, Indonesia's GDP per capita growth lags at 1.6%, below the regional average of 2.8%. This 1.2% disparity reflects the limits of conventional, static spatial management in a landscape that changes by the hour. The physical result of these rigid administrative systems is evident in the chronic, systemic gridlock found across major corridors. To reclaim this lost economic efficiency, urban management must transition from reacting to crises to actively modeling them. SCCIC and UrbanSolv address this by engineering an urban digital twin. This architecture bridges the gap between macroeconomic goals and physical infrastructure by synchronizing satellite-level GeoAI with street-level AIoT sensors to simulate the city's behavior in a real-time feedback loop. Achieving true megacity efficiency requires treating the city as a dynamic data ecosystem rather than a collection of static assets. The foundation of the digital twin begins at the macro level, pulling continuous satellite telemetry from platforms like Sentinel-2 down to a 3D topological map. Traditional geographic information systems, or GIS, typically describe the environment as it existed in the past. By integrating artificial intelligence, a process called GeoAI, the system moves into active forecasting. The system applies the Normalized Difference Vegetation Index, analyzing the health of every pixel and instantly flagging degraded environmental zones in red. This enables land use change forecasting. As the simulation runs forward, the AI maps how illegal development will expand into critical water catchments. This provides local governments with the exact data needed to intervene against illegal construction before permanent ecological damage occurs. When environmental protection fails at this level, the consequences flow directly into downstream populations, resulting in the chronic flooding across the Jabodetabek region. Here, pedestrians wade through waist-deep water beneath highway signs. This is the direct cost of ignoring predictive hydrological modeling. By feeding extreme rainfall data into the digital twin, planners simulate these complex scenarios. The simulation provides the technical evidence needed to justify spatial restructuring and the removal of illegal structures blocking vital waterways. Predictive spatial modeling allows authorities to treat these events as preventable zoning failures rather than unavoidable disasters. Once the macro environment is mapped, the scale shifts to the specific infrastructure networks that keep the city running. A digital twin relies on continuous, real-time telemetry from physical assets. This is handled by the AI of Things, or AIoT, a network where remote sensors feed data directly to an analytical core. At the microscale, this sensor integration manages individual building operations. In skyscrapers, the AI constantly monitors thermal and electrical outputs, automatically aligning energy efficiency targets with fire safety protocols. Zooming out, this same architecture is applied to the logistics of transit-oriented development. Consider the scale of the transport network required to move this commuter train. Every arrival and departure generates critical logistical data. State Railway Operator PTKI uses this AIoT architecture to coordinate secondary systems around their transit hubs, dynamically managing renewable energy, rainwater harvesting, and integrated smart farming. Through AIoT, static concrete infrastructure becomes a learning entity that adapts to the behavior of the citizens using it. The highest operational layer of the digital twin applies the simulated environment directly to public policy decisions. This interface demonstrates how planners address the urban housing crisis. With property prices rising 12% annually, administrators move sliders for zoning density and developer incentives. The map instantly highlights where affordable housing corridors become viable. Planners use the twin to stress test these zoning incentives in the virtual space before implementing them in the real world. This predictive capability also scales to logistical challenges, such as Indonesia's 69.2 million tons of annual national waste. Look at the management of the Ruritan refuse-derived fuel plant. These shifting data pathways represent collection trucks. As waste accumulation fluctuates, the AI continuously optimizes routing. By predicting where and when waste will accumulate, the algorithms keep the plant's 2,500-ton daily capacity at peak efficiency. This layer transforms public policy into a process of rigorous, data-backed resource allocation. The final test for an urban digital twin is applying it to a space that doesn't yet exist, a process known as greenfield area management. This is the immense physical footprint of Ibu Kota Nusantara, Indonesia's new capital project, currently under construction. For a project of this magnitude, the government uses the UrbanSolv digital twin as a pre-construction risk mitigation instrument. Algorithms simulate potential traffic bottlenecks and energy grid failures in the virtual space, allowing engineers to correct them before the physical infrastructure is finalized. The twin serves as a stress test, ensuring that the city's complex systems are designed to handle the demands of its future population. This visual captures the complete architecture: macro-level satellite topography, street-level sensor nodes, and predictive dashboards all merge into a single digital ecosystem. This technology was developed at the Bandung Institute of Technology, grounding these advanced AI concepts in a foundation of rigorous academic research. However, technical capability is only one part of the equation. For these systems to succeed, developers must prioritize data privacy and algorithmic transparency to maintain public trust. Dr. Fadil from SCCIC notes that accurate, objective data is the only rigorous foundation for modern public service. The ultimate goal of the urban digital twin is to create a framework for a mathematically sustainable environment, optimizing the relationship between a city's citizens, its economy, and its natural resources.